Saxon Algebra 1, Lesson 48. This lesson is about polynomials, degree, and addition of polynomials. Thus far, we have encountered expressions such as these: x to the negative third plus m over x, 2y over x third. I'm not going to read all of them. Just look at them. 4, negative 4a squared. The highlighted expressions occur so often we give them the special name polynomials. The other expressions are just terms or sums of terms, but they are not polynomials. A polynomial in one variable is a term or a sum of individual terms, each of which has the form ax to the n, where a is a real number and n is a whole number, such as the following: 4x squared, that's a polynomial in one variable; negative x third, negative 1.414 x to the 32nd power, 2x to the fourth, negative 7x, and negative 7. Each term of a polynomial takes this form. The negative 7 can be thought of as negative 7x to the 0. Remember, negative 15 to the 0 is 1. 75/14 to the 0 power is 1. X to the 0 is 1. X plus y to the 0 is 1. You get the idea. Anything to the 0 power is 1. Special polynomials. Monomials. X is a monomial. 4 is a monomial. Negative 4x squared is a monomial. A monomial consists of one term. 4x squared y is a monomial. 1/3 xyz squared is a monomial. Binomials. 7x squared plus 2 is a binomial. It has two terms. Binomial means it has two of them. X plus y is a binomial. 3x minus 4. X third plus 5x squared is a binomial. Trinomials have three terms. 7y third plus 3y plus 2 is a trinomial. X plus y minus 7 is a trinomial. 2x squared minus x minus 3 is a trinomial. Each of those consists of three terms. Prototypical polynomials. In one unknown, we could have something like this. The thing to look for is that all the powers of x are positive numbers or 0. Two unknowns. We could have something like this. All the powers of x and y are positive powers or 0. Three unknowns. Something like this. Again, the exponents are whole numbers. Here's the definition of a polynomial in one unknown. All terms are of the form ax to the n, where a is a real number and n is a whole number. Here's the definition of a polynomial in several unknowns. All terms are of the form ax to the n, y to the m, z to the p, etc. where a is a real number and n, m, p, and so forth are whole numbers. In other words, the exponents of the variables must be whole numbers. That means numbers like 0, 1, 2, 3, etc. Degree. The degree of a term in one unknown is the exponent. For example, the degree of 5x squared is 2 because the exponent is 2. The degree of negative 7x is 1 because we can put an exponent of 1 there. Remember, x to the 1 is x. The degree of a number, like 6, is 0 because it can be thought of as 6x to the 0. X to the 0, of course, is 1. When we have several unknowns, the degree is the sum of the exponents. For example, the degree of negative 7x third y squared z is 3 plus 2 plus 1. It's 6. We have to add the 1 for the exponent of z. The degree of a polynomial is the degree of the highest term. For example, in this polynomial, 3x third y squared plus 4x fifth y fourth minus 6x seventh y eighth, the term with the highest degree is that last term there, and its degree is 15, so the degree of the whole polynomial is 15. Descending powers. Polynomials are usually written in descending powers of one of the variables. For example, if we have this polynomial, 2x squared minus x fifth plus 7x third minus 9 plus 3x fourth minus 2x, we should rewrite it with the term having the highest degree first and so forth. So we write it this way. The x fifth has the highest degree, the x fourth the next highest, and so on. So the degrees are in descending order. Now consider addition of polynomials. Here are some examples. Add and write the answer in descending order of the variable. Here we have two polynomials being added. Since there's nothing in front of the first set of parentheses, and only a plus sign in front of the second set of parentheses, we can safely remove the parentheses. And now it's a matter of adding like terms, as we always have. The x thirds are like terms, they can be added. So when we add the x thirds, we get 3x third. The 3x squared is kind of a loner, and the 2 and the 4 add to 6. So this is nothing new. It's just like the problems we worked before, where we add like terms. Another example, a polynomial minus a polynomial. The first set of parentheses can safely be removed, but we have to distribute that minus sign in front of the second set of parentheses. So that means we have to change each thing in the second set of parentheses to its opposite. Now we can add the like terms. 3x third is a loner. 2x squared minus x squared is 1x squared. The negative x in the 7x is 6x, and 4 minus 5 is negative 1. So there's our answer, and the terms are written in descending powers of x. This is the end of Lesson 48. Your assignment, problem set 48 on pages 195 and 196 of your book.